Hi, welcome back to the shop, and welcome to another live stream here at EP3D. I'm your host, Matthew, and behind the camera pressing buttons, it's my producer wife, Emily. Say hello.
Hello.
Hello. She's going to be manning the chat as well and relaying your questions and comments in my direction so we could have a conversation and communicate. Today what we're going to do is work on my design process for the Hemera Revo XS to fit on any one of the Sidewinder or Genius 3D printer models. I've had a lot of people asking about this modification and setting it up for the Sidewinder X2, which I have, so that's what I'm doing. I did the regular Hemera with the Volcano on my X1 with a very similar setup, and now the XS Hemera with the Revo is all the rage, and so people want that on their Sidewinders and Geniuses. So here we are. So far I've just got the extruder, the mounting bracket, and a spacer for the breakout board on screen here. And the bracket is very similar to the one for the regular Hemera, just the hole offsets are a little different to fit for the Revo nozzle, to put the nozzle in the correct location. Also, they're tucked behind it nice and tight. You can see is a mounting position for a BL Touch or 3D Touch that nestles back in there just right. And with this, it puts the tip of the nozzle almost exactly in the stock position, so close that you shouldn't need to change your home offsets. Everything should just be fine as far as that goes. The next step in this process is to design up a cooling fan duct for the part cooling fan. Yes, I know I haven't saved. And the, excuse me, sorry. This program, like in the thumbnail said, this is SOLIDWORKS, and I did a video about how to get this, the maker's version. And it's straight up SOLIDWORKS Professional for makers, so there's a couple small things about it that makes it different than the commercial version. Mainly just watermarking your files. You can see here on the left in my assembly tree, it has this little M with the gear that just says, hey, this is a maker's version. It can't be edited in a commercial version. So, and that's basically it for that. All the other tools and options and abilities is all basically the same, except for plugins, no third-party plugins, but I wouldn't expect normal hobbyists and makers to be using third-party plugins for the kind of work that we do. So without further ado, let's get into it. If you have any questions, comments, concerns, whatever, put them on, you know, send them my way or send them Emily's way and she'll relay in my direction.
Well, Ray, Christopher, and Rich all say hello.
Hello, Ray, Christopher, and Rich. Nice to see you. Sorry we missed last week, but we had some stuff going on. Just didn't have time. What's up? Yeah, right, that was last week. Feels like it's been a month.
Oh, Drew says, word up.
Oh, word up. That was a good song. If you know what I'm talking about. Who was that artist? I don't know. So, yeah. So I'm in this assembly here. I have several parts here, and I got to put in a fan and start building some geometry around the fan, or between the fan and the tip of this thing, to get some cooling air in. So I've already got that fan open, so we're going to insert that in here.
For all of you watching, I apologize. I just realized that I had put Matt behind that subscribe button there.
Uh-oh.
So forgive me for that.
There's a subscribe button?
I think so. Or maybe it's just something I see there and they don't see it and I'm just being crazy.
Oh, yeah, that's like a YouTube thing. Yeah. So, uh-oh, we're stuck. This happens sometimes. There we go. That's not exactly what I wanted. It's easier if you orient the part how you want down here. I'm going to roll this around X. I think that's how that goes. And then Z. There we go. And then we're going to make this 30 degrees. And then what axis is that? That's the Y axis. Okay. There we go. That's what we want. Now we're in. And that just defines the angle of the fan. That way I don't have to tinker with it and try to use mates and constraints to make it go that angle. So it is free in here. So we have to lock this thing in place where we want it.
So Drew has some live update suggestions.
Oh, what's your suggestions, Drew?
I would love it if the fan mount has no adjustments. The Hemera XS Revo is in the same spot all the time. It would make it super easy to install.
Yeah, I could do that. Yeah. The reason for having adjustments on other ones is to fit, well, for my regular Hemera, to fit either a Volcano or V6. Plus, not all nozzles are born the same. Some of the Micro Swiss nozzles are a little taller, and so you might have to offset it a millimeter or two for that. But for the Revos, yeah, all the nozzles are the exact same height. So yeah, I could have it be in a fixed position. Good idea. See, already making my design process better. Okay, so let's figure out how we're gonna fix this thing in there. We're gonna start by setting the side-to-side offset. So mate this face and zoom in here, that face. And we're gonna just do an offset. And we're gonna start with just 5 millimeters for now, and we could change it later as we start defining this in space. One thing about this is that I don't want the fan, if we go over here, I don't want the fan to cover up the mounting holes too bad, or the actual structure. That way it's easy to install this thing. Some designs I've seen, can be kind of a pain where you don't have much room to get a tool in because there's interference, tool interference. So, but this distance from this surface and that surface is now defined and won't change until I tell it to change. So now, how high do we want it? And this is kind of a hard one to get. Sometimes you got to use some like sketches to get your constraints correct for this stuff. But just generally put it, oh, what in the, trying to move and drag at the same time. Generally get it where we want it. That looks okay. Maybe back like that.
And Drew says, oh, I 100% get why others have the adjustments with their Revo part. With the Revo, part of the idea, in my mind, is to always have it the same.
Yeah, which is a good idea. It's a good thing. All right, so what we're going to do is I want this edge to be on the same plane as that edge.
Ooh, he's calling me out by name. I'm getting an upgrade from the producer.
The producer.
Hello, Drew.
So if we click there and there, how does that makes it coincident? That works for me. I'll take it and we'll test it. Uh-oh, we messed up our angle. That's okay. That's okay, we could fix that. We'll mate that surface to that surface, and we're gonna do an angle mate, 30 degrees. Check. Now, can it move? Oh, it can move this way. All right, now we gotta do a distance mate. So we'll do this edge and that edge, give it a distance. Let's just kind of eyeball it here, scroll around. Haven't used my space mouse in a little while, I'm a little bit rusty here. That's a little too far. Let's try 8 millimeters.
Sure, blame it on the mouse.
Blame it on the mouse, 9. 9 looks good. What? Oh, I scrolled. Check. All right.
Rich says, I have such a hard time with programs like this that what you're doing is basically magic to me.
When I first saw programs like this, I definitely saw it as magic, and I immediately gravitated toward it. In high school, I gravitated toward AutoCAD. I switched from, I wanted to do graphics design classes, and then I saw AutoCAD, and I was like, oh, I definitely would rather do that than play with Photoshop. And now here I am. So now we got to define this. They're laughing at me. They're all going to laugh at you.
Drew says, what a flex, though. My space mouse. Nerd alert.
I've had this mouse. You could switch to it to show the people.
Oh, okay. So you got to use your fancy view there. Hang on one second.
I spent some time getting this view.
I got a There you go.
Right. So I've had this combo, the Space Mouse, or the Space Mouse and the CAD Mouse. I've had this combo on my wish list for, I don't know, 4 or 5 years now, almost since it came out. Like, I saw it and I was like, that looks amazing. You could program all the buttons, and it doesn't only work in CAD, it works in games and applications. You could program all the buttons for each game and application you want. I mean, I have program buttons for Google Chrome and all that stuff. It's really neat. Using it and getting used to it is, takes some time, some crud there. But it's a lot of fun. So, yeah. All right, so.
And Drew, I call him a nerd all the time. Every time he pulls out like this program or something like this, I'm always calling him a nerd. So the tone is like already set.
Yes. I was tinkering with this program years ago. Just, I don't know what I was making, just random stuff. And she's just like, nerd, you'll never do that for a job. Why do you spend so much time messing with that? Well, now I kind of started the 3D printing department at work, and I use this program to design parts. So technically, I get paid to do it now.
You know my job is to give you a hard time.
It is. You get paid to give me a hard time.
And Rich joined the bandwagon and says, wow, and here I thought I was a nerd.
Right, okay, so this first distance mate, we're going to edit that. Edit feature. And then we want to...
So,
I want to go normal.
taking a quick poll in the chat here, how many of you would like a bit more explanation of what is happening on screen?
Yeah, I kind of get going here and get into my head. Okay, we're going to normal to that. Oh, why does it do that? Rotate there. I believe that's the button. There we go. All right, now we're normal to that face. That's our distance mate, edit feature. We'll flip it, we'll go that way with it. Yeah. It would be nice to have it directly on center, but then this hole for this fan blocks that. So it's going to be a little bit offset. We're gonna move it over another 4 millimeters. We'll just make it an even 10. There. So these two holes are not blocked. That hole unfortunately is, but the idea will be to install this thing before installing the fan. So we'll have 3 fasteners mounting the whole shroud to the extruder, and then the 2 going through the fan. All right, and then we'll unlock our rotation here, and that, oh, I'm all over the place. So, yeah, that looks pretty good. Air floweth down and cooleth the plastic. Plenty of space there.
So Rich wants to know, so what's so amazing about the Revo hot ends that make them so much better than the stock ones on the Artillery machines?
A lot of it's the Hemera extruder is amazing. You have a much shorter filament path, and it's a tighter filament path. So your extractions can be much shorter and faster. So one thing that can affect print speed more than just how fast the printer moves is the amount of extractions and the length of the extractions, and obviously the speed of the extractions. So with the stock extruder, I do about 0.8 to 1.2 millimeters of extraction at 25 to 30 millimeters a second on a stock extruder with PLA, and that can change a little bit depending on the PLA. On the Hemera with the Revo, I have my extractions at 0.5 millimeter at 40 millimeters a second, and all things being equal, speed, acceleration, that's almost, I think I measured almost 6 to 7 minutes faster on a benchy, just in extraction speed. Yeah, or retractions, not retractions. I'm using the wrong word. Retractions, yeah. So that can make a huge difference in your printing speed. And then obviously, the less amount of time you spend retracting material, the less effect it has on the overall quality of your print. So your seams will be much better. Actual print strength could be improved depending on how your model is and what kind of infill you're using. And then beyond that, it's all metal. You could do up to 300 degrees, so you don't have to worry about any melting of the PTFE tube. And then with the Revo, it's super easy to switch nozzles around. So you get the full kit, you get 4 different size nozzles, and it's toolless. You don't need to use a wrench and hot tighten and all that kind of stuff. They say you could do it with it still hot. I don't recommend that. There's a little silicone sleeve on there, but it still gets mighty toasty. But you can go and, oh man, I want to print with a 0.8 millimeter nozzle. Takes just a couple of minutes to switch it out and you're good to go. So it's amazing, and the print quality too is amazing. So I love it.
So while we've got you here, Drew wants to know, when you're designing things like these, you just design on the fly, or do you have some idea in your head prior to designing?
So I have a little bit of an idea in my head. I kind of start out on the fly. I mean, it does depend on what I'm doing. And sometimes it's half and half. Like, I'm just going to wing it, but I still want a little bit of a design purpose to it, like a look or an intent to it. So I know this is going to be an air duct, right? So I know that this needs to flow air from two sides of the nozzle. So I have to keep that in mind when orienting the fan and how high the fan is. I don't want the air to have to move or change directions too much, because air is lazy. So moving the fan at this angle helps that air have a smoother path than if it was straight vertical. And I've done some airflow testing in the commercial version of SOLIDWORKS. Premium has a really good airflow testing, and between having the fan vertical and just at that 30 to 45 degrees makes a pretty big difference in the turbulence and the speed of the air coming out, and it can make a fan seem much better than it actually is just by doing it right. And then there's some design intent. How is this going to be printed? Because this is going to be a 3D printed part, right? So what's the easiest way to print it without supports, or with as little supports as possible? And then on that, fastener setup, excuse me, access to fasteners, the types of fasteners that are going to be used. So it's a little bit of both. And some things I just like, oh, I just whip this up real quick, no big deal. And some things I put a lot of time into. Like a fan duct, I spent some time practicing and just doing fan duct after fan duct after fan duct, because it's a little bit more complicated than what I'm used to. So I've sped up a little bit, but still a very time-consuming process. I hope I explained that right. I don't know. So from here, we need to add a new part to this assembly and use the assembly to constrain the new part. So I'm going to go up here, insert components, new part.
Ooh, so Rich asked a question. There's a little bit of a chat going on.
Yeah.
But asked a question I'm curious about too. Do you find yourself, and he was asking Drew, but I'm going to ask you anyway, do you find yourself switching print heads often? Why would you switch out a print nozzle?
It depends on what you're printing. If you stick with things that require one size nozzle, then it doesn't really matter. That's not a feature that is a huge thing for you. For me at work, some of the things that I print, I want to be, for like prototyping, I want to print faster. So a larger nozzle you could print much faster because it just more material gets laid down. And for strength, bigger nozzles will create a stronger part because you have less layers, less areas for things to separate, thicker extrusion lines. And sometimes, high resolution isn't required for a part. I'm not really tinkered with it much at home, mostly at work for some things. Like an example is I made these little shades, little hoods for these lights, these overhead lights in one of our sims that blocks the light from the eyes of the instructor because they're super bright LED lights and they're super distracting. So with a 0.4 nozzle, it was 2.5 hours plus, depending on how fast I was printing the PETG, between 2.5 and 3 hours to print it. And then I switched to a 0.6 nozzle and it took 40 minutes off of the print time, which doesn't seem like much, but when I got to make enough for 2 sims plus spares, it helps. The time it helps, it really does. 8 of them I had to print for a set for each sim plus a spare. And that saved a substantial amount of time. So, and other than that, it could be an aesthetic thing. If you like thick, really thick layer lines on a part for the aesthetic, it could be fun. I said thick and she's smiling. Get your mind out of the gutter. Or you can go down to a point, I think they make like a 0.25 millimeter nozzle, and you can get incredibly high resolution prints for an FDM printer. It's all preference, really. So, all right, back to your part metric. Okay, and then it wants me to name it. We're in the right folder, so we're going to name this cooling, caps lock on, cooling duct V1.0, because there's always different versions. Save, and then pick a plane. So we're going to pick the face of this nozzle as our planar face. And then we are going to normal 2. Hey, what's going on here?
You also have Mike Jones with us. He says, cool.
Mike Jones, what's up? Cooling duct, okay. Interesting. Oh, I see what I did there. Okay, so we are in the part editing environment within the assembly, and you can tell because all of the lines in the assembly tree for that part will be blue, and then everything else will be black. So we know we're in the part editing mode. So while we're here, we're going to click on. We're going to start with some reference geometry. We're going to do a plane, and our first reference is going to be this face, and we're going to offset the height of your first layer, typically 0.2 millimeters. Check. There we go. Check. All right, and we will kind of spread this out here. You don't technically have to do this. I just don't like having the edge of the plane lines in my way while I'm drawing. Now, one thing that has happened is the origin of this nozzle is not in line with the origin of the part. So it's going to be tricky drawing some of this stuff. So when I go over here and go to sketch, it's going to automatically go normal to the sketch, which is just facing the planar face of the sketch. And so all of my lines I would normally have constrained to either vertical or horizontal vertices, I can't use, so I have to get creative with it. And the way to fix this is just to rotate the nozzle around till it is in the correct orientation with the origin of the model. But I want the wires to come out in this direction, so I know where my interference is, and those wires are going to go toward the breakout board anyway. So part of the challenge. So we're going to start with this sketch, and we're going to figure out the distance from the nozzle where the outlet of this duct is going to go. So we're going to do it with a circle.
So Mike says, hey, I was just thinking about airflow today. When the print head moves so fast, I kind of wish it blew some air behind it. So this is how you design it. Very cool.
Yeah, you want to make, so there's so many different ways to do it. You have obviously air coming from one direction, 2 directions. There's some out there that's like a ring, which is kind of cool, but you got to have the fan that could put out enough air to do that. So you have to balance it between the amount of air the fan can push and the velocity of that air from your outlet. So if you have a smaller outlet, you have more air velocity. If you have a bigger outlet, you have less air velocity. So if you use a small fan with a huge outlet, you have almost no velocity, and it's going to not help you. So going with a stock fan that blows an okay amount of air, but trying to split that and have that come out of a larger surface area or a larger outlet like an entire ring, you're not going to have enough velocity for it to be effective. So part of my having done this a lot on other just practicing is I used airflow testing excuse me, to see that velocity and get more of a real-time simulation of how it works. And then it proves right when I go and do test printing because they work incredibly well. So for here we're going to do a diameter of, and this is just kind of eyeballing it for now, 35 millimeters. Yeah. we might go a little smaller, but 35 seems about right. And we're going to turn that.
So Jonas is with us and asked if we have a website we can check out. I added the link to the website in the chat for you, Jonas.
Perfect, Jonas. Would that be Jonas Lade?
Yes, it is.
Oh, hey, buddy. How are you? Thanks for joining. Now, this is where it gets funky. Luckily, I have these lines here on the nozzle. It looks like that. No. Oh, that's my dimension line. So go from here, and we're going to attach it to there. And I want this line and this edge to be parallel. And that constrains this line to this direction on the model, parallel with that direction. And so that gives us a good starting point for constraining this thing at this funky angle. Normally it'd be easy because I could just tell it, oh, you need to be horizontal or vertical. But if I do that, it might do things incorrectly as compared to the origin of the model of the actual extruder here. So
Jonas says, just another day at the office, enjoying the stream.
all right. Oh yeah, it is. It's Tuesday.
Don't remind me.
Don't remind me.
It
Oh
feels
boy.
like Friday.
Right? So, and a huge portion of this stuff is you'll spend a lot of time when you get into more complicated things. Spend a fair amount of time doing reference sketching because you're going to use these sketches as reference for constraining the 3D geometry in the future. And so as you learn this type of software, you have to learn an order of operations. So say I do all this and I say, hey, this is way too close to the nozzle. I need it to be further away. I could use this. Where's the dimension for it? It's hiding from me right there. I could change that dimension and then the model would update after it if drawn correctly. So then what I could do is I could take this dimension, double click on it and give it a global variable. We will call this outlet distance. Outlet distance. We got an equal sign in front of it, I believe. There's a way to do this. Oh, yeah. Here I am being stupid and I can't remember how to set this up as a global variable. Outlet distance is the name. Oh. Equals 35 functions. Okay, we go over here to where are my equations? Exit sketch. Should have equations over here somewhere. Huh. Tabs, toolbars. The software updated on me and everything got moved. So I've been slowly working on getting my UI back to how I like it. All right, coming over here, I should have, there we go, right here, an equation. And there's, I forget exactly how to tell it to be a global variable, but it's the same difference, right? I can come in here and just change that. Oh, I want that to be 40 millimeters, done. Okay, and it rebuilds the sketch. So later on, I can go in and instead of having to go back to the sketch and edit the dimension, I can just go up here to equations, find outlet distance, and then change whatever dimension I want for it. It's super fast and easy. And rebuild, and it changes everything parametrically, hence parametric modeling. So that is my outlet distance. We are going to, let's see, do another center line. Edit sketch. Do another center line here, zoom in, and come over here, we're on there, and we should, nope, it's not gonna snap. Dimension, that to that, where are we? It's going to be 90 degrees. So you'll see the sketch lines go from blue to black, and blue means it's not constrained or not fully defined, and black means that it's fully defined. It's best to use fully defined sketches. Otherwise, you could accidentally click and drag on a point in a sketch or a model, and it will change everything, and you won't know what you've done, and you won't know how to fix it, and it can be breaking very bad, very, very bad. Okay. It didn't like doing that, so we're just going to draw another line. Sometimes it gets a little weird with the constraints, and I don't know why. That's one I haven't figured out just yet. And we're just going to make those collinear. So I just hold Control, click on my two lines, tell it what constraint or relation I want, and it forces it. There we go. And it's getting hard to see here. So we're going to go Row View. There we go. Now I can see. We're going to unlock that. And we've got to start. And that looks pretty good. So, exit sketch. We are going to do another reference geometry plane, and it's going to be at the end of this model, at that point there. And that, no, perpendicular, there we go. That's not what I want. There we go. Sometimes you just kind of click around until it works. That's part of figuring out how to do this, is just clicking around and playing with it. There we go. Plane 2. Hey. Sketch. Do I have planes turned off? I do have planes turned off. There we go. Now I can see.
You know what it is? I agree. I agree with Rich. This is all like magic. I think I'm just jealous. That's why I call you a nerd all the time, because this is kind of cool. Nerd.
Nerd. Yeah, it's... Anybody can do this. People that say, oh man, you're way smarter than me, I couldn't do that. Anybody can do this. Just, it takes the time and the effort and a little bit of a mindset. If you don't have the mindset, then sure, I guess you can't. But
you know me.
You possess
Anybody
the ability.
cannot do this. I cannot do this.
Well, you cannot math.
Okay.
So, but you did trigonometry in math. I never
did calculus.
You did calculus, right? I never got past like a little bit of geometry. So technically, you math better than me.
Well, I think the thing is in calculus, like 2 + 2 = 5 doesn't really matter.
Right. Oh, I was sketching there. Add sketch. Hey, there we go. Oh.
We have Tobin with us and says, hello from Texas. I really enjoy your content. You've been really helpful. I just wanted to pop in and say thank you.
Thank you, Tobin. Welcome. I appreciate that. We're going to get out of component mode here.
Ray says, yeah, but trig is easy.
So I've learned a little bit about trig just in some of the YouTube videos I've been watching about machining and using sign plates to calculate angles and stuff like that. And that helps me understand it better. When I saw a little bit of it in school, I was so confused. Like, I don't understand all this. This is silly. So back to here.
I will say I use trig like every day in life. No.
Now, here we go. Now we're in the money. Now we can see what we're doing. We'll make sure we're locked here. All right, so now we got to figure out the angle of the outlet. So we're going to do a sketch line this way.
Same, Drew. Once I got into trig and calculus, like, I loved those classes. I never use it, but those were so fun.
Right, and then this way. So I'm using this point as the edge of this, and that's our outlet point.
Rich says, if you give me all the parts with no directions, I could put it together. But trying to put something together virtually like this, my brain just says, error, doesn't compute.
Error doesn't compute, so so what I can do here, there's when you're in software like this, there's typically never just one way to do something. So I could add a dimension to make this 90 degrees, or I could add a relation to make it perpendicular. I'm going to do the latter, click on the two lines, and just make them perpendicular. That way I don't have a dimension blocking my view, because a lot of times you'll start adding dimensions and all this craziness, and then you can't see your actual sketch. There's just dimensions everywhere. So you use a mix of dimensions and relations to define everything. So then I could drag that, and no matter what, that's going to be perpendicular. So we do need to give this a distance of about, let's see, 1.5 millimeter thick walls. I want an outlet of 4 millimeters, so 7, right? And then this is where it gets fun, and figuring out how, this is like an eyeball. You'll eyeball it, right? To start out with, like, okay, that looks about right. Oh, these need to be vertically constrained. Oh, it won't let me. It will just do a center line between them then.
See, now that we talked about trig, I'm just seeing triangles and thinking about...
So many triangles. I can't stop it. All right, so that should stay. Okay, there we go. All right, so now I need this.
Oh, Drew's wife is a surveyor in northern Alberta. Alberta land surveyor. That's kind of cool. Does lots of trig.
Lots of trig.
Yeah.
In
that sounds fun.
Alberta land.
I think Alberta land surveyor, not like Alberta land, like.
Oh, it's not an amusement park? I thought all of Canada was an amusement park. I mean, I went to Whistler once. That was an amusement park for sure.
Oh my goodness.
I know, terrible. So this point, I'm having a hard time. Sometimes sketch points can be a little difficult to get constrained how you want. There we go. And we're just going to delete that sketch point.
Drew says those BC hippies.
BC. Yeah, right.
I feel like that's the equivalent of somebody saying, like, I went to Disney World. I've been to America.
Yeah.
I mean, I don't think you can lump a lot of what happens in Florida in with the rest of the country.
Right. Okay. Oh, I need a point on there too. What is going on? Sometimes, there we go. Whoa.
Ooh, Ray used to live in Nova Scotia. They had lots of moose and coastlines.
Moose. Okay. Oh, please. Why is this not cooperating? I don't understand this. Why? Sometimes it does things that I don't understand, like this point. For some reason, it will not let me. Nope, that's not working. So we'll just add a line. And I know this line is going to be constrained to the circle that it is drawn on. Hopefully. No. Oh, come on. There we go. No. Something is weird. Oh, you know what? I know how to do this. I have an idea. Nope. Check that out. We're going to, there we go, and make that a construction line. So what I just did there, I was having a hard time getting anything to constrain to this point, because this point is, it would be a quadrant of that circle, and for some reason it just did not want to do that. So this tool here, Convert Entities, it will take any curved line or spline that is displayed normal to you on your sketch plane. It will make that a 2D line in the shape of, it's kind of hard to explain. So this is a circle here, right? But let me unlock this. I clicked on it and it just drew a line that is
radius
with it, right? I was hoping that my lines here would work for other constraints, but they weren't cooperating. No big deal. So now when I go and if I change this, it's going to change all of this together, right? So drag that there, Now we're fully defined. And then, there we go. And we could change that angle. And what we could do is that we could just define a distance between the bottom of it to where the top of our print would be. Go back and go normal here, lock this. So how far do we want the bottom of our cooling duct to be from where our print would be? I think 2 millimeters is acceptable. Okay, there we go. Now we're getting somewhere. We're getting an idea of what's going to happen here. If the air's coming out of here, blowing this way, we got to think of how it's going to spread out from the outlet, and if it's going to cause any cooling issues here. Obviously, the thickness of the wall will make a difference. Will play to that. So I think 35 millimeters may be a little too small, and I don't remember what I did for the last one of these I did, but that's okay because I could just go over here and add to it, and everything should update if I did everything right. Okay, bam, and that looks much better. And that is the joy of this kind of software, because you could set up your variables and constraints and things that you know might be a dynamic or a really driving feature or dimension. You could set that up as an equation or a global variable, so it's easy to change and drive your whole model geometry very simply and quickly. Because man, it's like spend a couple hours drawing this whole thing and all of a sudden, oh, it's super wrong. You go to try to change it and then it breaks the entire thing because you did something in the wrong order or didn't define something correctly. It can be super frustrating. And I spent hours, years learning. Okay, so that is that. I like that. That is good. We are going to go back to this sketch.
So Drew asked, can SOLIDWORKS do a visual for the airflow?
So the Maker's version does not. So the airflow simulation is part of SOLIDWORKS Premium, which is the third tier of SOLIDWORKS. Like SOLIDWORKS has 3 tiers. You have SOLIDWORKS Standard, SOLIDWORKS Professional, and SOLIDWORKS Premium. The Maker's version falls under the SOLIDWORKS Professional tier, so there's no built-in airflow simulation, sadly. That is something that would be really nice for them to add, but I don't see them doing that because a lot of makers that use it aren't doing that. It's not something that I see as a very marketable thing for most makers. Do I see it as beneficial for a lot of makers out there in the 3D printing space? For sure, it would be nice to have this. So I have access to a commercial version of SOLIDWORKS Premium to do that. There are other programs out there online and stuff like that you could do it with. Michael at Teaching Tech did a great video about what he uses because it's all online and it works pretty good, and I've tinkered with it and it's pretty decent. But being that I have access to the SOLIDWORKS version in the commercial setting, I prefer that over the online version. Not to say the online version is bad, I just prefer what I already know how to use. So check out Michael at Teaching Tech. He's got some videos about it, and he actually uses Onshape. It's an online version of a parametric modeling solution that is actually pretty capable and not bad. So, nerd. All right, we're back here. Now I want to mirror this over to the other side because I'm going to do the same thing on the other side. So, and it is undefined, so we're just going to define it. The length of this line doesn't necessarily matter, but it might get mad about having an underdefined sketch. So where's my mirror? Mirror. Select that, select that. There we go. So now these are constrained to these. So if I change any of these dimensions, these will follow it. So I could like double click on this and then we're going to call this equals functions. You can give all sorts of functions. 2 millimeters, all right. And then we're going to call this height offset, bed offset, bed offset. Bam. And I'm kind of cheating. These should technically be global variables, but I don't remember. I haven't done it in a little while. setting it up, but it works just the same if you use it as an equation. You just don't have an equation in there. But you could add, like, if you're good with Excel, this works very similar to how the functions and stuff like that, math works in Excel. So, all right, that is that. Now, unlock our rotation. We have some stuff. Let's hide this plane. Hide. Why are we still? Oh, you know, okay. So now we need another sketch plane coming off of here. So features. Are we still in the sketch environment? No. Oh, reference geometry, plane. I think I have a button for that on here. I do have a button for that on here. I should use that. So there, there, and there. No. Try that again. Plane. And oh, it's gonna want to do. I want it to be parallel. Now I'm feeling kind of dumb because I can't remember how to do this. There, and then there. Okay. Perpendicular. There we go. It's all about the order. And there. Sweet. Okay. We're getting somewhere. I promise. All right.
You got 12 minutes.
I have 12 minutes. This is a time-consuming process. So if you all like this type of content as far as doing this SOLIDWORKS live stuff and you want to see more, let me know, because we can make this a series, because I could probably do this in several parts. It is a slow, time-consuming process, especially if I'm doing this and talking at the same time. I'm not good at that. Right?
I didn't say anything.
Mm-hmm. All right, we gotta actually escape. We are going to convert entities. Turn that to construction geometry. Normal 2. Now I have, come on. Lock. There we go. So now, there we go. There's my line. We are going to do a rectangle. I'm just going to draw it outside of my area and bring it in to where I want it. So that line and that point are going to be coincidentally constrained. That line and, ooh, what point is that? That point. And that line. There we go. Bam. Okay. We are going to add a construction line from midpoint to midpoint this way. And we're going to have that line. Where's my control button on here? I know I have a control button. Ah, here we go. And that line to be collinear. All right, so now I have it. I could adjust the width of this thing. Where are we at? This way, and it will always stay center to this plane that is center of the nozzle here. So, yep, that's fine. Line properties, and we're going to give that a dimension, and we're going to make it. How wide should we make it? Class, how wide should we make this? Anybody? Bueller?
In real measurements or in fake news measurements?
In fake news measurements. I'm that weird American that draws everything in metric for the most part.
I think you were good just stopping it. You're that weird.
Yeah, I'm that weird. Let's start 20.
Drew says 25.
25? Let's do it. That looks good to me. Yeah. That works. Okay. Check. Look at that. Now, we gotta do the same thing over here.
Ray says, holds up fingers about that far.
About that far. right? Hide this plane.
It's my kind of measurements. I like that.
Right. This is going to be a fun series. I'm excited. This is going to be a fun series. If you guys want to keep doing this as a series, like, seriously, this is going to be fun. I want to do it. I want to do it. I'm having fun here. I love this. I'm a nerd. Man.
See, I knew if I kept putting it out there long enough, you'd just accept it. And
I've always accepted it. I've just not been vocal about it.
Mm-hmm.
No, exit sketch, back to features, plane, do, and then that, and then that. Yay, okay. Now I just got to remember everything I did there, I'm going to do there. Or
I have no idea what may have given him this idea, but Drew thinks that you might want to do a modeling series.
yes, that is something I've very much considered. And I guess it wouldn't be too hard to do, just screen capturing. It's not like I have to deal with cameras and white balance and exposure and focus and lights and tripods and holy cow, you guys, you have no idea. The video I'm working on right now that hopefully should be published in the next week, I've seriously probably got close to 100 hours into, and it's a 15-minute video.
Drew wants to know, could you not have just mirrored what you just made?
I think you can. In fact, we're going to attempt that. We're going to attempt that. What we do need is we're going to hide this plane. We need another reference geometry, another plane. We do that and that. And I think this one's going, yeah, there we go. Okay, in our features, we are going to, why is it not giving me that option? Not in a sketch. Typically it would be here, right? What if I, oh, I gotta rebuild? Sketch. Yeah, it's not giving me that option. I think, oh, I don't have any actual like 3D features yet. I don't think it lets you mirror over sketches, only actual features. So I think that's why I automatically just went to doing it manually, sadly. But there's a fix for this. There is a fix for this. We are going to do an extrude, and we're going to pick that. And we're going to extrude that out. We're just going to start 4 millimeters. Now I can mirror it because I have mirror face or plane. Bam. Features to mirror, click on that. It didn't like that. Why didn't it like that? What in the... What did it say? Edit feature. Propagate visual properties. Huh. This should have worked. This is as simple as it gets. Why is it so mad?
While you're fidgeting with that, I'm just gonna sneak this in right here.
You gotta sneak in the drawer of the finished ones too.
Oh, that doesn't come out though.
All right.
If the drawer came out, I could do that easy.
Right.
Oh man, not far enough. You gotta pull it back towards you. Darn it.
Or we could.
I guess. Hang on.
Oh, shinies. Just showing off here. Okay. I don't know why. New full preview. Yeah, I don't know why this mirror is not. It's not wanting to do it. That's strange. This is as simple as the geometry can get, and it doesn't want to mirror it. I don't know why.
Drew says, do you need to select the object versus the face?
So when I go to do it here, features, I'm mirroring the feature. So if I wanted to mirror a face, right, I can clear this. All right, that would just select that face. Let's see what it does. Yeah, clearly. Could not attach pattern to faces. Okay, so clear selection. So we have the mirror plane, which is that.
So you have somebody joining us from Turkey. So it says, hi, I'm following you from Turkey.
Hi.
Perfect timing, by the way, on this. So you're very educational. Will there be alternative BL Touch video for the Sidewinder X2? The BL Touch probe part on it is constantly breaking. Can we produce different solution, less costly, more useful?
Funny you should mention that. The video I am currently working on, yeah, you can just go back to me. The video I'm currently working on, and I'm like close. I'm very close. The edit is done. I'm just adding music, and then I gotta finish putting these together because these are part of it. So within the next week or so, I'll have that video published, and it's how to take off the stock probe and install a inductive end stop as a leveling probe. And it's as detailed as it gets for instructions down to how to crimp the contacts on the wires for the new probe. And I'll have firmware for both the X2 and Genius Pro with touchscreen firmware as well that will function with it perfectly, and a designed bracket to mount the new piece. So, and it will be for one of the Artillery ones. They're just Chinese clones of a Panasonic GL8H or whatever type inductive proximity sensor is what it is. So yes, that is the very next video in short words. But we are running out of time here. It is 3:57 and this mirror is not working. Drew, this should have worked. I'm sorry, Drew. I don't understand why. I've done something wrong. But I'll figure it out. But
so, throwing out a quick before we have to go, shout out, you have on your website, you have your forum.
Yes, a community forum on the website now, which I've been actually admittedly neglecting. I've been busy, but I got to get on that and get more active on it. I've got some active users, and I appreciate it. It is very nice to have people on there, and it's a way to get away from, the Facebook and stuff like that. If you want to post something about an unrelated topic or whatever, like on the Sidewinder forum, I can't post stuff about my SP5, right? So if I do an SP5 video and I want to show you guys or let you guys see that I've done this video or I'm doing a live stream about it, well, I can't post that in the Sidewinder page or the Artillery page in Facebook. So you may not see it because YouTube notifications are iffy at best. So I could post stuff like that on my community forum and obviously on my Facebook page and Instagram page. So whatever you prefer following me, social media wise, that's just another option for people if they want to go that route. It seems like I feel old saying it, but it seems like an old school way of having a social platform is on a community forum. That's kind of how it started. And then MySpace and Facebook and all that kind of.
So our hope to build that up is a good platform where you can all have conversations about what you're updating, what you're doing, current projects you're working on, issues you may be running into, communications about how other people are fixing it. Mm-hmm. But a space where you're not worried about possibly being censored. I know Facebook's getting really weird these days on the just smallest terms they're picking out, and they're flagging people and taking down posts just for something that maybe wasn't actually. Yeah,
they're construing things as political that really aren't. And
or even if you say one word that just happens to catch the oh my goodness, sorry, one word that just happens to catch the algorithm, and it wasn't actually political. You didn't say it; it just happens to catch it. So please let us know what's going on. We're going to be better about posting what we've got going on, more pictures about these boards that we're finishing up, hopefully this week.
Yeah.
So come on in and have a chat.
Absolutely. And I'll be on there more. And my producer wife here, she's going to be my social media liaison for the forum. Liaison, it's a good word.
So if it sounds like he has no idea what's going on, it's because it's me and I have no idea what's going on.
Yes. Yeah, that's perfect. She'll learn. We'll teach her. Right, so that is all the time we have for today. I'm sorry I couldn't get any further. This is a time-consuming process. We will continue this series if you want to. Let me know. Message me, Facebook, whatever, community forum. Let me know if you want to continue this as the weeks go by. But we got to get going.
Drew asked real quick, any update on the print beds?
They're ready to be ordered. We just have to order them. We're down to that. So they're coming. They are coming. But thank you guys for hanging out with me and having a chat and asking your questions. I love your questions and I love chatting with you guys. You can follow me on Instagram and Facebook at Ethereal Project 3D. Also on our community forum on the website at etherealproject3d.com. Also, if you want to, buy me a coffee. I'm on Ko-Fi now, or Coffee, or however they say it. Link in the video description. Check it out. Thanks for watching. Happy 3D printing. I'll see y'all later.